Hello, everyone. So, welcome to part two of Murder in SQL City. Last time, we found a list of witnesses that gave us valuable information. This time, today, we have a lot of work because we need to figure out who committed the murder in SQL City. Welcome. Who do you think it was? Let me know in the chat. I don't know. I saw Juan being suspicious. I'm gonna say that it was Juan. All right. So, in the meantime, we are going to be working with Intro to SQL Part 2. So, go on your training portal and make sure you open this one. It doesn't really matter if you go on Part 1 or Part 2 because we're going to be using the same database. But if you want, just click on Part 2 so you are there. Yes, I know that we didn't finish part one, so I'll pick it up from there. But so you're not switching cases, you can just still work through that one. But yes, I'll pick it up from there. But the important thing is that you go on Codio. Once you're on Codio, my recommendation would be go on the mysterious CTE affair. Click on it. Let me refresh my Codio because it's not working for me. And oh yeah, so I have to open this. And yeah, the mysterious CTE and click on the Start SQLite browser because I know it's a little bit slow for some people. So while I introduce the case again, make sure you click here so you see your SQLite. Um, and what I did last time, in case you want to do the same thing I'm doing, I just uh, click and drag here to make this really big so I can see the code properly. And I click here on this window. It works just like Windows computers, just to cover the whole screen. Um, So that's what's happening. So yeah, while I introduce the what we're doing today, make sure to go on page 4 and click on Start SQLite browser. So you um, start loading that. If you need to refresh Codio again, if you have any issues, you have the time to do that. What are we doing today? So today we're doing part two. There's a lot of queries to go through, so it's gonna feel fast. This is probably the fastest class so far. So don't worry if you're not following along. My biggest recommendation would be at home to try to do all the queries from part one and part two on your own. So pause the video before I give the answer. Try to do it on your own, and then check the answer. This is very important because just like learning a language, you need to practice that language so you become fluent in it. If you're not making errors, then you're not practicing enough. It's completely normal to get errors, get warning signs, get a different stuff. That's how you learn because next time that you have the same issue, you know, okay, now I know how to fix that error. So it's very, very important that you practice and you get those errors. If you're not getting errors, it means that you're not practicing enough. So let's do a quick recap of our case last time. So last time, we know that there was a murder in Sequel City. It happened on February 18, 2018, not 2028, 2018. And from exercise number 2, we know the crime description. Exercise 2 of the first part. So the description is a security camera in the neighborhood captured two figures who might be witnesses. The first one lives on 513 Hamilton Drive, and the second one was identified as George, who lives on Independence Street. So from that, we were able to gather these two clues. In exercise 6 and 7, we were able to figure out our witnesses. using those clues. So the first witness is Fidel, and the second witness is George. And we got these statements. So on exercise 8. So that's what I'm going to go over again. And let's get started. So I'm ready to solve this mystery. Who committed the murder in Sequel City? We'll find out today. Um, so once you have your database open here, uh, well, not database, DB browser open, let's open our database. So the same thing we did last time. We click here on open database. It's this crime database.db. We click on it and we open it. So here we can get rid of this block here and this one as well. And oh, okay. So now we have more space to work with. So we had the 7 tables that we can see in this ERD, entity relationship diagram. This ERD is usually provided to you by the data engineer, so you know how different tables are connected to each other. You can visualize your data here in Browse Data, but what we really need is here the Execute SQL tab to write our query. So exercise 8 in the first case was basically we wanted to know, we wanted our result. Let me show you what we wanted to achieve. We wanted to achieve our result to be a table that said here name, and the name will be our suspects, so Fidel and George. And then here it would say the description, which is the statement they gave to the police. So that's what we're trying to achieve. But the issue is that we have that information over 2 tables. So we have the individual table, which provides the name, and the interrogation table, which provides the description. So that's why we had to use a join. So that's the very first thing we're going to do today. It was what we did last time, but I know that we did it a little bit in a hurry because we were running out of time. So I'm going to do it a little bit slower today. So that's what we are going to be doing. So how do we create this table such that the result is I want name and description. Name that comes from the individual table and description that comes from the interrogation table. So let's first see how we will put these 2 tables together. So the way to do that is let's do select. I'm gonna write. It's I'm gonna have to refresh my Codio because it's not letting me write. So give me 1 second. So if you were not here, this is great. Your opportunity to catch up. Okay, now I can see. So let me get rid of this. Okay, so going back at what we were saying before. So we need the individual table and the interrogation table. So we do select star. So we always start our SQL queries with select. Star means give me all the columns. In this case, what is that gonna mean? That's gonna mean I'm gonna grab ID, name, driver ID, address, social security number, income, individual ID, and descriptions. I'm gonna bring all those columns in there because I just said star. So it's just give me everything. So in this specific join, there's different joins that you're gonna learn with Swati, I think next week. But in this specific join that I'm gonna show you is called the inner join. What that means is that it only matches data that exists in both tables. So for that reason, it doesn't matter which table you call first. So let's just call whichever one first. So I'm gonna say from individual, but you could have said from interrogation. It would have worked just as well. So from individual, join the other tables. So this is the grammar on how to do that. So join the other table. The name of the other table is interrogation. And then you have to let Excel, Freudian slip in there, but then you have to let SQL know how to connect these 2 tables. So this ERD is not great. Some ERDs show you exactly what to columns connect to each other. So in this case is individual ID with interrogation individual ID. These two columns are the ones that connect the table. So I'm just telling you. So you have to write that in SQL. So it says on. So you have to have from table, first table, join, second table, on. And then you say, okay, I want the ID column from individual, that ID equals interrogation, that individual ID. So this is the ID column from the individual table, and this is the individual ID column from the interrogation table. And then semicolon, and we run this query. And look that the result, what is the result? Here, it looks just like the individual table. But here at the end, I added the other two columns, which is the description and the individual ID from the interrogation table. So this is just combining the two tables. You you could almost think of it as an index and match kind of type of thing. Um, and here it's matching based on ID. Wherever this ID comes from this individual table, wherever this ID was exactly the same as this individual ID on the interrogation table, it matched those rows. So that's what we got in there. This is how a join works. And now you can join any table, any number of tables that you need. But specifically for this exercise, we don't really care about all the information. We want the name and we want the description. So instead of calling all the columns, here we're going to remove that star and write, okay, I want individual that name, comma. So individual that name, I'm going to extract that column. And then from the interrogation table, you're going to extract the description. So if you were working with one table, you wouldn't need to refer to the table. But since we're working with two tables, you need to say, okay, we want the name column that exists in the individual table. If you don't do that in this case, it would be fine. If you wrote just name, it would still work. The issue is that if you had here a column also called name, then SQL wouldn't know which two columns to use. So it's always good practice to refer to the table that you want to extract that information from. So I run this and then I get this result. So notice that whenever you build a query, something that helps me personally is to imagine how my result should look like. So I said, okay, my result should have a name column. So this is the name in here. And then a description column. So this is the description. So I always imagine the result and then I build my select from there. And then we don't really care about the description that all the witnesses gave. We particularly care about Fidel and George, and we know their ID numbers. So we can use where because we already know where. So where individual ID equals 201 or individual ID equals 328. So I run this and then you get the result. One neat trick in here, because here we only have two witnesses, so we can say this or this, but imagine you had 100 witnesses and you needed to say individual ID equals 201 or individual ID equals 202 or individual ID and 100 times that, that would be a nightmare. So a trick that you could do is that instead of having all of this, you could say in 201 in parentheses and 328. So those two queries give you exactly the same result. This is just like, okay, when the individual ID is in here. So it's one of those two values. And then you get the result in here. So we got our witness statement from George and our witness statement from Fidel. So let me copy this query in the chat so you have it for your reference. Let me know if there's any questions with how the join works. If you're not being able to write in Codio, I had the same issue. I just refreshed by using this button and then it worked. Um, but yeah, so that's the join. So that was the exercise number 8 from last time. And yes, you use the semicolon only once at the end. So make sure that you only have one semicolon. And here, this is where we got the witness statements. So we read the witness statement from George. What I do is that I double click on it to open this window. And then I click here on the symbol to see all the text. So just double click on the symbol to see all the text. And then George didn't really say anything valuable. It says like, oh, for the rest of the way home, I recited to them the various exploits and triumphs of Hercules. So doesn't really make sense. So we ignore that. But Fidel had some good pebbles. So I double clicked on Fidel. So Fidel said something important, which is what I copied and pasted in here. He said, I heard a scream and then saw someone run away. I thought it was just a robbery. After all, we're in Murder Sequel City. But then I saw the pool of blood and freaked out. The guy that escaped accidentally left a card from the Muscle Hassle gym. The ID member number was damaged, but it starts with a 33. A minute later, I heard the tire screeches and saw a car pass by real fast. The plate had a CDI or something like that. So now we're getting super close to figuring out who committed this crime. So that was exercise number 9. The first part of exercise number 9 is using the gym table to extract this information from the gym. So let's take a quick peek at the gym table since it's been a while. So select star from gym affiliated, limit 5, just to see what do we have here. So here we have, okay, ID, individual ID, name, start date, and status. So the clues that we have is they work out at the Muscle Hustle gym. So that's gonna be our status. So I can start with that. So I'm gonna remove the limit and I could say, okay, select start from gym affiliated, where status equals Muscle Hustle. And once you have that, it says the ID member was damaged, but it started with a 33. So this is the ID member, this column. So, and ID. But since we don't know the exact number, we have to use like, remember from last time. So like, and then it starts with a 33 and we put our placeholder. And that's our query. So we run this and we have our 4 potential suspects. So from exercise, so or list of suspects. List of suspects. And that's from exercise 9. We know that our suspects are these people. So I'm just gonna copy and paste their information. So we have Krista, we have Hercule, we have Tris, and we have Braun. So this is the 9.1. Let me copy and paste this query. I'll put it in the chat so you have it for reference. And Hercules sounds suspicious, right? This is the second time we see Hercules. So we have these four suspects now, and the very last exercise from the last lecture was okay. Now that we know these four potential suspects, um, we should retrieve their all their individual information. We want to know everything about them, but we also want to know everything about their driver's information because we had the license plate, which the license plate is ZDI. So if you missed the join, how to join two tables, I'm going to do it again. Now I'm going to be joining the individual table and the driver's table, but to get the information about these four suspects. So I'm going to be doing it again here. So some people think it's Braun that committed the murder. So we'll see. So this is exercise 9.2 from last time. So let's do this. We need all the information on the individual table and all the information on the driver's table. So how do we combine those two tables? So we do select star because we want all the columns from, and then here you can put whichever table first. I'm going to say individual and join. You always have to say from first table, join on second table. So the second table is drivers. And these two tables, how are these two tables connected? Well, I'm going to tell you because here you wouldn't really be able to tell you from this visualization, but on the individual table, driver's ID has to match this ID on the driver's table. So that's how these two tables are connected. Some are ERDs are a little bit more clear, like you would see an arrow going from here to here. So you know this is exactly how these two tables are connected. But in this ERD, it's not clear, so I'm just going to tell you. But if you're at work and you don't know how these two tables are connected, you could either look at the two tables and try to make a guess or ask the data engineer because the data engineer would for sure know. So that's what we do next. So on individual driver ID equals driver's ID. So this connects the two tables, but here we have the information from everyone. We have all the individual table, which is up to income. Look, you have name, driver ID, address. Well, you have everything, and you have also everything from the driver's table. But we don't care about everyone. We already know our suspects, so we can filter by these suspects. So that's where individual ID in one of those four people. So 647, 146, 981, and 45. So we run it, and there you go. So now we get all the information on our four people here, or four main suspects. So I'm just gonna put it here in our notes so we continue investigating this crime. Oh, that's messy. I'm just gonna leave it here. So this is the main query that we need for now. Maybe some of you might already know the answer. Maybe, because it says, oh, the plate had a CDI. The license had a CDI. So since it's not that many suspects, we could even open this up. And we could see, oh, look at the plate, CDI. It seems like Tris was our murderer. But remember, we're in the US, not guilty until proven otherwise. So we have to prove that Tris did it. So Tris is our main suspect right now. And this was easy for us because we only had four suspects, and only of them had a license plate that started with CDI. But imagine if you had 2,000 suspects, that could happen, and many of them start with the same license plate. What do you do? How do you query those tables? So that's what we're going to be doing today. So this was the last query from last time. If I know that that was a little bit fast, but we have a lot of content today. So this is the query that we're going to be working with today. And then now I'm going to start with the content for today. So I'm going to copy and paste this in the chat. I see from the corner of my eye that there's a few questions. So I also take a moment to answer some questions. Let me put the query in the chat. This is the main query that we need today for now. And this query is basically telling us all the information that we have on our main suspects. So we have the name, the address, the income, the age, the gender of or for suspects. To copy and paste the query from Codio is control, even if you're in a Mac, because this Codio space exists within a Windows computer, if that makes sense. So you have to use control regardless on what computer you have. So control C and control V. Control V if you have a Mac outside of Codio, then command V. So let's see some of those questions in the chat. If here in the select statement, you should always have stuff with a comma, separated with a comma. So for example, if you have select star, comma, the name of a column. So here in the select statement, you always have names of columns separated by a comma. So that's an issue I have seen in there. So for example, um, I see hope, but I think someone already answered. You're missing the from. Let's see what else where already we have. Um, let's see. Um, Make sure that you don't have more than one semicolon. The semicolon should go only at the very end of your query. It should happen only once at the very end. Otherwise, it's gonna break your query. Let's see what other issues do I see in the chat. I think it's the semicolon issue. I've seen it a few times. Yeah, so make sure that you're having the semicolon only at the very, very end of the query. Um, if it's not working, the Control C, Control B, maybe try with right click and just clicking through the buttons. That might work better. Um, if or that could be a Codio issue. So if you want, of course not now, but later you could download DB browser. It's free. You can have it in your computer and that issue wouldn't happen anymore. All right, cool. So let's take a moment to breathe, do a quick recap. What was happening? We were going through the last exercise of last time. We needed to be able to get all the information possible from our list of suspects. So this is the last query that we finished on. And now we are going to start with case the part two. So in the part two, I was telling you, okay, so we have this query, and naturally, I will want to be able to query this table. For example, the next question I'd like to ask is, um, I would like to say something like select a star from this result where played like ZDI, because I know that's one of my clues. Like here, I can just look at it and it's easy because we only have 4 suspects. But what if we had 2,000 suspects? It would be very hard. Is there a way I can query this result without having to maybe do, because potentially you could do like another filter here. And where plate is this? That would also work. But what if you want to have like some statistics on your suspects? Are most of my suspects men or women? Are most of my suspects middle age? all those questions that you will want to answer, I will want to query on the results because I already know that I want to work only with these suspects. I don't care about the rest of the people in my table. So that's what we're going to be doing next. We have two ways to do that, to query on our results, because at the end of the day, this is also a table that we can query. So how do we query on that table? So we have two options. The first option is called CTE. So CTE stands for Common Table Expression. Um, so first, we're going to do it through the CTE. And the second option is through a view. So you can say, um, you can have those two options. So let's do it with a CTE. So what is a CTE? A CTE is a way to basically put in parentheses, a big parenthesis, your query, and then run a new query on top of that query so you don't have to modify your original query. Um, so this is, we're going to create a CTE on this. So if you're not getting only four names, maybe you don't have this filter here. This is probably the thing that you're missing. So, okay, let's create the CTE. So how do you create the CTE? I'm going to modify this query. So the first thing I do is I'm gonna insert something before I start my query, and the format is the following. So you say with, and then you give it a name. This name could be anything that you want. In the Codio guide, we have CTE suspects as, and then you open parentheses, and all of your query, you close the parentheses to have all of that in that big parenthesis. So you have to get rid of this semicolon and you close the parentheses. So that's how you create a CTE. So we have just created the CTE. This name is completely custom. You can give it whatever it is. It's going to be the name of your new table that you're going to query. So you can name it even chicken. Like I could put here chicken, and this also works. You can name it literally whatever you want. I'm going to, of course, follow the Codio guide, which is CTE suspects. But that's just for the sake of consistency, and also you should give it names that you know what it means. So city suspects is probably a common table expression for the suspects. So basically a table about the suspects. So you create it this way, you run the table, and of course this breaks because you now need to do a query on the city suspects. So how do you do that? So after you have closed these parentheses, so notice that even here DB browser tells you, okay, here this parenthesis is open in here and this parenthesis closes in here. You have all of the query, original query in here. And now you can say something as simple as business as usual, like select everything from city suspects. So now you can treat this as a normal table. And now you can put the semicolon. So you run it and there you go. So you get the same result. So you might be wondering, but why did I just do that? I already had the result in here. But the advantage is that now you can start having fun with the CTE suspects. So you can have fun with the table of the suspects without having to worry to recreate this query again. So for example, if you wanted to know, well, I want to know the eye color of my suspect. So I say select eye color. I see this. Um, you could go back here. We know that the hint is that the plate ends in ZDI. So you could say where plate like ZDI. And you run this. And then you gain your main suspect. So the whole purpose of this is to make your life easier. Once you have created like this filter, in this case, it was a filter of instead of extracting the data of all the people that we have in our database, we only work with our suspects. Imagine if you were actually working for the FBI in the US. You don't want a database with the data of all 300 million people in the United States. because that's like too much people. You only want the table with your suspects. You probably wouldn't have just the four suspects. You will probably have a few hundred suspects. And then once you have already created the conditions to have your pool of suspects, then on that pool of suspects, you can ask questions in there. So that's the whole purpose of a CTE. So let me send you this in the chat so you have it for reference. This was, yeah, so let me put it in. Yeah, it is a table of a table. It's exactly, that's exactly what it is. So let me put it in the chat. So, Christy has a great question. Does this table show up now in my list of tables? So let's check here or in the database structure. Notice that we don't have a CTE here, nowhere to be found. We only have our normal tables. So the issue with the CTE is that you always have to have the CTE in there. If I delete the CTE and then I run this query, it gives me an error. It's telling me not such table as CTE. So that's the only disadvantage of the CTE is that you always have to have it here on top of the query you're gonna do below. Um, what if you wanted to not have the query in here and just have it stored kind of like a table? That's where the view comes from. But let me see in the chat if we have questions in the chat. Yeah, so the CTE is not saved in the database. So it's just basically like a filter that we can work on just to make our queries easier to read and to understand. Kevin has a great question. That's how you should think as a data analyst. Can I do this in an easier way? Yes, you can. You could have just done the where in here. Uh, Given that we only have this very small data set, you could have said like your query and then where this and plate like this. So in this example, because it's a small example, doesn't really make much of a difference if you do a CTE or if you just put it in there. But the CTE is an advantage when you want to do different queries on exactly the same data. So you're not rewriting your query, your main query every single time. Let's see. Gladys, I see a small typo because you called your city suspects, but then when you call it, you skip the letter P. So make sure to have your type exactly the same. And how did I know that so quickly? And this is just so everyone knows. I look here at the error and it says not such table as city suspects. And at first I was like, but she has the table. So then I was like, oh, it's probably a typo. So that's how I realized it was a typo. And that's why I was saying it's very important that you practice these things because if you're not getting errors, it means that you're not practicing enough. Because next time, I'm 100% sure next time you see this problem, then you're gonna know how to fix it on your own. But please feel free to keep sending those errors so I can address them and answer those questions. Why is this red? Whenever something is in quotes, DB browser makes it red. Um, if it keeps erasing those other lines, might be a Codio issue. Just like refresh Codio. I know that a little bit cumbersome, but you can fix it that way. All right, so addressing some of the questions. Let's see who it was. I think it was Shinsuke that asked, well, what if I don't want to have this query in here? Is there a way I can somehow store these results? And the answer is yes. So there's something better than a CTE, which is a view. So how do you create a view? So a view is almost like a table. I'll tell you in a second exactly what a view is. But basically, this is how it works. So this was our original query. I'm gonna get rid of the CTE. This was our original query. the very first query that we did to get our suspects. So to create the view, again, before the query, I would say create view. I'm gonna give it a name. I'm gonna say v2 underscore suspects as, and then the rest. That's it. You don't need parentheses for this one. For the CTE, you need parentheses. For this one, you don't need parentheses. And notice that if I go here on browse data, I see my tables. These are the tables that I already have. And when I execute this query, I'm gonna run it. Nothing happened, but now that when I go to browse my data, look, I have the one that I just created, which is this v2 suspects. I didn't use v suspects because it already existed. So if I try to rerun this query again, it's going to give me an error and it says it already exists. So that's why I switched names. One way to avoid that error when you're creating that view is to say, okay, create view only if it doesn't exist. And then you avoid that error. And here again, with this name, you can give it any name that you want to this view. You can name it chicken if you wanted to. Not a very good name because nobody's gonna know what chicken is. But here, look here. Now I created this chicken chicken view. Don't do it because it doesn't make sense. But you can literally give it any name that you want. So now that I have this view, let me put it in the chat so you can do this at home. Let me put it in the chat so you have it. Now that you have this view, you can get rid of it and now treat it as a table, like select star from the suspects. So that's a nice advantage from the view because you don't have to have the query in there. You can delete it and it's already there in your database. So a view is not exactly a table. A view is like a mask on your table. So you're not creating new data, you're just filtering your data through a query, but then you can treat it as a table. And then when you go in here, you can distinguish the actual tables because they have this table symbol versus the views that they have this like three symbol in here. Like it's like a landscape, and these ones actually look like a table. So that's how you distinguish them. A view is very useful. For example, something that I loved last class is that people were concerned about the social security numbers. And this is exactly what you need to be thinking as a data analyst, how to protect your data, because your data is your most valuable asset. So you need to protect your data. And of course, you don't want to risk people getting social security numbers. So for example, if you're a manager and you have a data analyst that is like low on the chain, you don't want to expose them to social security data. You don't know them. What if they steal this social security number and do bad things with it? So you can create a view without the social security number and give them access to just the view, not the original table. So that's one option. So that happens a lot in at work. You have access to views. You don't have access to the actual tables. The disadvantage of views versus CTEs is that the CTE, once you're done, the database is clean. Here we're creating stuff in this database, which is like not ideal if it's something that you're gonna use only a few times. So if it's something that you're gonna use only a few times, I will go for the CTE. If it's something that you're gonna use every single day again and again and again, then I will go for the view. That's the difference between the two of them. But they accomplish the same result, which is once you have a query and you wanna do a query on those results, then you can do it in a easier manner. So let me answer some of those questions in the chat. Can you delete views? Absolutely, yes. So to delete a view would be drop view and the name of the view. So let's drop the chicken. So drop view chicken. We run it. And there you go. The chicken is gone now. So you can do that. Be very, very careful when doing this when you're at work. I always double ask if you can drop that view because you don't want to drop a view of like one of your colleagues that created this massive query and then they lost that work. Or same with tables, you don't want to drop a table with that guy that get rid of the data of the company. So whenever you type the word drop, be like extra careful. Like please don't use it as often. Um, so there you go. So Drew has a great question. The CTE is only visible for exactly the where you have it. So if you have several tabs, the other tabs don't see the CTE. Um, all right, cool. So that was the view. So in the database, we actually already had the view. So maybe I know that this first part of the lecture went a little bit fast. From now on, from until the rest of the lecture, we're gonna be working with the view that we just created. So now you know what a view is. I know that you guys are gonna have to practice it. I think is in the extended case number 3, number 4, in one of those extended cases. But for now, you can just treat it as a normal table, so you can follow along. But before I move on, let me share this image in the chat. Is there any way to recover drops? No. Once it's gone, it's gone. So that's why I was like, be very careful if you use drop. And here, this is the image I wanted to share before I moved on to the next topic. So this is the difference between where. Oh, no, no, this is not the one that I wanted to share. It was this one. Ignore that one. Not yet. This is the one that I wanted to share. I'll put it in the chat. Um, so this is the difference between a CTE and a view. A CTE is not stored. The view, it is stored. And what's the use case? So the CTE for queries that are referenced only a few times. For queries that are referenced again and again and again, the view makes more sense. Um, this is something that also when you start working is going to become pretty obvious. I remember one time I was writing a SQL query again and again at work, and I was like, oh, this is so annoying. And then I was like, oh, wait a minute, but I learned about views at school. Like I should use a view. So then it'll become obvious when you're repeating processes at work, and you're like, oh, maybe this should be a view. But yeah, like I said, for now, we are gonna now work with aggregations. So if you wanna, um, now, like it's fine. You can do select start from the suspects. So I think we actually reached a good stopping point. So after the break, you're not gonna have to create a view. You're not gonna have to create a CTE. We're gonna work with aggregations on this V suspects table. So I'll give it back to Juan. I say 5 minutes and then we come back.
Okay, perfect. We are set to begin a 5 minutes break. So then I'm going to pause the recording here. If you have any questions, remember, please direct those to the extra help chat. Okay?
Thank you, Juan. All right, so we are back, and I have good news. I know that the first part of the lecture was a little bit loaded with a lot of information, but now I'm going to show you something that you guys already know from Excel, which is aggregate functions. We're going to do the same thing that we were doing in Excel, which was count, sum, average, minimum, maximum. I'm only going to teach you how to do it in Excel, in SQL, but it's the same thing. The other good news is that the view of the suspects was already in the database, so everyone should have it. Even if you didn't write the create view and so on, you should be able to run this query no problem. So that's what we are going to be working on. So let's say you didn't know that the plate had a ZDI. You only hear things here and there, and maybe you heard that your suspect is a woman. So let's filter by gender here. So let's say select star from these suspects where gender equals female. And this is the same as we've been doing. We see that we have two suspects that are women. But what if your manager tells you, hey, I want to know how many women do we have in our data set so I can know how many investigators do I need to go ask questions to allocate resources. So in here you can say two because you're seeing the two rows. But what if you had a much bigger table where you had a million suspects and you don't know how many women you have? You're not gonna count one by one. So how do we count rows in SQL? So to count rows in SQL, it's here on this star, you do count star, count in parentheses this star, and then the rest is the same. So here you see, okay, the count is two. So two women in our data set of suspects. If you wanted to know all of it, well, remove the filter. Then you have four people in the data set. So you have count. So that one is as you would expect it to be. Yes, so female has to be case sensitive because it's an equals. Whenever you see an equals, it has to be an exact match. So let me change it here. See that it says zero. So it is case sensitive. So let me put this in the chat. And so you have this query for reference. There it is. Yeah, Braun is a weird name for a girl. I agree. Okay, cool. So for exercise number two, no, exercise number one. So the first exercise of today is the following one. Write a query to find out how many drivers are recorded as male. The hint here is that we're not using these suspects, we're using drivers. So I'll give you 2 minutes so you can try it out on your own, and then we'll do it together.
2 minutes left. Left. Seconds left. Seconds left. 5, 4, 3, 2, 1.
All right, so I want to send claps because I am happy with what I'm seeing in the chat. So one thing when you're presenting interviews, especially SQL interviews, half of the task is to read the question correctly. So if you just change here female to male, it wouldn't be the correct answer because the trick was to switch the table. So you needed to switch the table to drivers. So maybe it was not an issue of, I don't think anybody made that mistake, but if you had that issue, that was the point. So we were working with the drivers table, and we were counting how many men were in that table. So it's 497. I saw a few people getting 1,000. Maybe you didn't put the filter, so you're just counting how many people you have in the driver's table. But the question says how many drivers are male. So you do need the filter in there. So this is how you get the correct answer. Right. Okay, so let me put this in the chat. And let's continue. So now let's talk about what we all like, which is income. So let's look at the income of the suspects. So select star from the suspects. This is our normal table as usual. But let's say you only wanted to look at gender and income. So here you can say exactly what you want. Instead of the star, you can treat this as a Christmas gift list and ask exactly for what you want. So in this case, let's say, okay, I exactly want to see gender and income. So a few things. Make sure that each column is separated by a comma and that you don't have a comma here at the end because that would create an error. Like, let me run it. This is fine. If you have an extra comma here, it gives you an error. So it says error here, and it shows you where the error is. So you shouldn't have a comma in there. So this is okay. This is cool. But what if you wanted to see the average income of the group? So what is the average income of the suspects? So let's get rid of gender for a second. We see the income. And to do the average, it's another SQL clause. So the SQL clause is going to be this one, average, the SQL word. And you have to put it in parentheses. So average of income. This is the average of the income of all the suspects, which is $44,000 per year. But what if you wanted to do the equivalent of a pivot table? So in Excel, this is how the pivot table would look like. You have your genders, your income, and you want to know what is the average income per gender. So how do you do this in Excel with a pivot table? Well, in your rows, you have the gender, and then in the values, you put the average of income. Now I'm going to teach you to do this, but in SQL. So in SQL, my strategy is always to visualize my result. By visualizing my result, it allows me to write the query. And I approach it this way whenever I have a job interview or when I was in school, I had a test. This is how I would approach it. So the question is, what is the average income per gender on my database? So I would like my result to look something like this. So I would like to have here gender and here average income. And then here, well, female, male, and whatever their income is. And the reason why this helps me, because now I know I have to write two things in my select, because I have two columns. So I say, okay, in my select, I want first gender. Here, what happened here? First, sorry, my Codio is acting out, so I'm gonna refresh. Okay, okay, now it's working. Okay, so I will have here gender, comma, average income. So this is gonna give me the two columns. If you have two columns, you're gonna have two things separated by a comma here. But I need to create the aggregation. The same way here in Excel, we said, okay, we are gonna aggregate here. In SQL, the way you do it is with, okay, I'm gonna do group by. And what do you want to group by? You want to group by gender. So you have to say, okay, I want to get my average income per gender. So I need to group by gender. And we do it. And notice that we get exactly the same result that you would have gotten in Excel. So this is how you would do it in Excel, and this is how you would do it in SQL. So you can see it side to side. But yes, exactly. You can see. Um, so I see your question, Drew. How come each gender is repeated? Is because we have four suspects. So just so it happens that we have two women and two men. But if it said men, 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 it would mean that we have four suspects that are just men. So that's what we were seeing here. But now we are seeing it aggregated. So now we see the aggregation in here. But let me know if that didn't make sense. I can go over it. All right, so we have that. There's one little thing that if you're OCD like me, it bothers me, is that this title looks very ugly, right? Like average income. So if you want to change the title of a column, right after the column, you can type something like as, and then whatever you want to name it as. So for example, average income or whatever you want in there. So that changes the name in here. So it looks nicer. So let me copy and paste this query in the chat. So you have it in the chat. And now we let's do another one. So let's go with again with the suspects. Select start from the suspects. What is our next question? Suspects. I saw a question about the view. If you missed the view, that's fine. You should have it in your database so you can directly query from it and catch up later on with the recording. So here we have our data that we're working with. Let's say we wanted to know who's our oldest suspect. So again, for me, it helps me visualize the result. So I would like my result to be something like name. So I know the name of my suspect. And then age. But this age is going to be the age of whoever has the maximum age. And yeah, that's it. So let's do this query now. So how do we see who's the oldest person in this data set? So if I did instead of select star, I do select okay, now it's working. So select name, comma, age. This is just showing me the name and the age of each one of the suspects. But I want to be able to obtain the name and the age of the oldest suspect, which in this case we know it's Braun, but how do we do that? So we say name, comma, and then max. So this is another aggregating function that you already know from Excel. So select name and the maximum age, and then you run it, and then there you go. So you get your result. And if you want to create an alias, so a nickname for this max age, you could say here as, and whatever you want to name it. So let's say oldest. So there you go. So now you have the name and the age of the oldest person. So I'm going to copy and paste this in the chat. I see a question that I like. Can you filter numbers with the greater and less than symbol? Yes, absolutely. You can do that. And in fact, we will be doing that in the next example. So this is something you do a lot of times when you're working as a data analyst. So let me show you the data set again. So we have this data set and we have here the age. So let's say, again, name and age. And for the suspects, yeah, for the suspects, it could work, but I've done this quite a lot in marketing. Because in marketing, I don't care if my client, I was gonna say if my suspect, if my client is 78 years old or 79 years old, that doesn't make a difference to me as a marketer that I'm gonna create some type of advertisement for them to consume. But I care more about, are you a senior? Are you a young adult? Are you an adult? Are you a kid? So I can just create a marketing campaign for that bucket of people. I'm not going to create a marketing campaign specifically for people that are 78 years old. I just want to bucket people in categories. So this is something that you do quite often in data analysis. If you were working for the FBI, for example, it could be something like you got a tip that your suspect looked like was in their mid 30s. So you would just get everyone that is in their 30s. So how do you create that? I would like to have here another column. So I have name here, check. I have age, check. But I would like to create another column that says that is age group. And then if it's above 65, I would like something like, okay, if it's 18 to 25, then it's young adult. If it's 26 to 65, then it's adult. And then anything above 65 is a senior. So I would like here a column that this one, okay, Brown will be a senior according to this. 58, this Hercules would also be a senior. Krista would be a young adult. And Tris would be an adult. So how do I create this new column? So in Excel, you would do if the column is between this, and this, and then you would create it with an if. How do we do it with SQL? With SQL, it looks a little bit scary at first, but I promise you it's not difficult. You just have to be patient and not let it startle you at first, because it's going to be a lot of text that we're going to have to write. But at the end of the day, all of that text is going to create this column. So that's what we're going to be doing next. And that's called case one. So we're going to be using a case one. So here I already have my name. I already have my age. I'm going to leave it as is. I need to refresh my code because it's acting up again. So here, okay, I have name, comma, age, comma, and my next column should be my age group. But how do I create that column? In theory, I could write everything that I need to write in here, but the issue is that if I write it in here, it's going to be difficult to read. So that's why I'm going to put it on a new line, but it's still the same concept of adding another column. So how does it go? You have to say case. You start always with case. So case one, and you give it your first case. So your first case, I'm going to put it in parentheses so it's easier to read. So when age, so this column age, is between the ages of 18 and age is less or equals to 25, then what would be that label for this group of people? So the label for this group of people would be young adult. Then you go with your next case. So when age greater than 25 and age less than 65, then they're gonna be adults. You could create here another case, which is like when age greater or equals to 65. But since it's our last case, instead of writing when, we can just write else. So all other cases are going to be a senior. And then you have to write the column, you have to write end. And then the name of the column, you can name it whatever you want. Let's say this is our age group. So what is happening in here again? This name is creating this column. This age is creating this column. And all of this code that looks super long is going to create a column called H group. So that's what's going to happen next. So let me show you. And once you run it, this is what happened. And basically here to create this column is using these scenarios. So grammar of case one, you have to put case and you have to put end. And then all the different cases are handled with when. So when, and you put your conditional in here. It could be anything that you want. So for example, it could be instead of age, you could do income. So low income, mid income, high income, rich, poor, middle class, whatever you want. So you can do these cases however you want. And yes, if you know another programming language, it's going to feel very familiar. And you're going to think about this once we do it in Python. We're going to be doing this in Python as well. It's going to be very similar. And yes, of course, I can send it to the chat. Let me send it. Oops, sorry. Let me resend it because that sent incorrectly. And let me resend this. And there you go. And let's see. Okay. So something that so I see your question, Drew. How come that we have to create this age group? Because if we don't put it, then the title becomes this, which is very messy. It doesn't work like other programming languages. I see where your question is coming from, but here you don't have to declare anything in advance. You just have to make sure that to avoid this ugly title, you put a name right next to it. So H group or whatever you want to name it as. And this is not going to be in our table. This is only going to be in this query. So for example, if I go here to browse the V suspects, it's not here, the H group. It's only in this query. So this will be an excellent scenario to create another view if we actually needed these labels. Will we get the same results if we use when instead of else? My favorite way of figuring things out, let's try it. So the answer is yes, but let's try it. What if we skip this else? So when age greater or equals 65, that will be seniors. And let's do it. There you go. The reason why you should have else is that else captures all the cases that you might have not mentioned. So for example, here, there's an issue with this query. Right now, there's not an issue, but before there was an issue because we were saying else, which is everything else, make it senior. But we're not accounting for people that are less than 18 years old. So they would have gotten labeled as seniors because we're saying else, make it that. So a better use case would be else. So the cases that we didn't mention here, I don't know, something like not a valid age because maybe you don't want to process minors. I don't know, something like that. So you should use else to cover your bases for cases that maybe you didn't even think of. So that this will be a better way to create that query. This query is even better. So I love your question, Jamila. That was an excellent question. All right. So that was case. Let me put this in the chat as well in case you guys prefer this query instead of the other one. So now imagine, okay, I have my age group, but instead of this result, imagine that you wanted a result that looked like this, age group. This is a little bit of a challenging question, and I'll give you a little bit to think about it, how would you answer this question? So you have here the age group. So here it will be senior, adult, and young adult. And then we have two seniors in here. So I don't know, something like a count. So two seniors, one adult, and one adult. So basically, you want to create a pivot table, but using that age group that we just created. How would you do it? And feel free to try or make it a guess. Make a guess. I'll show you how to do it in a few seconds, but just try to think, how would you approach this question? How would you create a pivot table using age group and count? Any ideas? You don't need another case. You don't need a having yet. We're gonna get there. But we do need a group by, so that's good thinking. And we need a count. Exactly. So good job there. So let me tell you how I would proceed. So if this is what I'm being asked, if this is what I need to deliver as a result, what do I need? I need something that creates this column first. So basically, this whole block of code. Then I need something. I don't need name and age because I don't have it in my result, but I need something to for count let me do this in orange. Count the how many occurrences that we have. So I will have here comma, count star. This is how you count in SQL. And then you need the group by. So group by. And what are you grouping by? What are you aggregating on? On the age group. So age group. And that should create this result. So let's do it together. Yay! I see it in the chat. Awesome. Awesome. Yeah. So let's do it together. So if I remove the name and age here, this whole block creates this column. But now I need the next column. The next column is the count. So I'm gonna do comma. You have to put comma. This is before you had name, comma, age, comma, because those were columns that already existed. But now this age group column doesn't exist. So you need to put whatever you need for that. So that's why we have this whole block. But I want to demystify this block. We don't need to be scared by this block. This whole block, what it's doing is creating that that column for us, this column for us. That's why when I only have this whole block is creating this column. And then I need comma, I need the column that counts. How many instances do you have? So count star. But I need to count per age group. So I need the group by. So the group by always goes after the from. So group by age group. And there you go. So now you get the result. So notice that I knew my result was going to be two columns. So I have my first column is all of this. And then my second column is just this one. And I needed the group by to let SQL know, hey, we're creating this type of pivot table by using the H group. And then if you don't like the look of this count star, you could say as total or as total. Let's just name it like that. And there you go. Now it's fixed. So again, this whole block here produces this column, and then this piece here produces this column. So anything that is separated by a comma, if you're given someone else's query, you can tell how many columns there is, even if they start putting crazy stuff like the case. It's still there. So let me put this in the chat so you have it for your reference. Copy and paste. There you go. And now let's go with exercise number 3. Exercise number 3 is going to be very similar to what we are doing so far. It's just you have the opportunity to do it with a different tables. Let me show you exercise number 3. So exercise number 3 says, no, this is example number 3. Let's go with exercise number 3. Now you have to write a query using the individual table. So we're no longer going to be using the from table. We're going to use the individual table. And based on the individual table, we're going to create income labels. So for people making less than $35,000, it's going to get labeled as low. For people making less between 35 and 50K, it's going to be medium. And from people making more than 50K is high. So I'm going to give you 2 minutes. You can try it on your own. Then we'll do it together. The logic is very similar to this logic. What changes? It changes, well, you don't need no, you do need a group by, but it's no longer the suspects table, it's the individual table. And instead of working with age, you're going to be working with income. If you have any errors, please feel free to share them in the chat so we can all learn together from those errors. And I'll give you 2 minutes and then we'll do it together. Let me know if there's any questions.
2 minutes left. Left. Seconds left. Left. 5, 4, 3, 2, 1. Time's up.
I know that was probably not enough time, so let me give you 1 more minute and then we can do it together. All right, I see a few answers in the chat. That's fantastic. A few errors. That's also fantastic. We need those errors to go through those. So there you go. Okay, so let me do it together. Let's do it together, and then we can share that answer in the chat. So we need to do the income, the income. So let's select for a second. Let's just do for a second. Let's review the individual table. So let's select income from individual. So we know what we're working with, individual. Okay, so this is our income, and we want to create labels. So we want to be able to say, okay, this income that is 63K, that's high. Well, in this economy, I would dispute that, but let's follow the example. So this one is high, this one is high as well, this one will be medium. So how do we create those labels? So we create those labels with case. This is the perfect time to use case. So comma, case, we do the first case. So when income less than 35,000, so 35,000, then low. Next one, when income is greater or equals to 35,000. So notice that I'm putting greater and equals. So I covered the 35,000 because if I do this, then if someone has exactly $35,000 of income, they're not going to get any label. So I have to include it somewhere. And here it's site inclusive. So I'm going to put it in here. And income less or equals to 50,000, then medium. You could have said here else if you wanted to. That also would have worked. I would prefer to do when income greater than 50,000, then high, and then else, I'm gonna put else like in case, think of like someone maybe accidental instead of writing a number wrote like a text or something, so not valid. So I'm covering all my bases. But if you put here else high, then for this example, it will work. And then we finish it. So end. Let's give it that column a name. That will be income group. So let's run this. So what is happening so far? We're not done, but here we have this income. This is this column. And then this whole block is creating this other column. But that's not what the question is asking. The question is asking how many people are there in each category. So we have the categories, the income, we have the labels, but we want to count how many do we have. So we don't need the income anymore because we only need the labels, but we need to count how many labels do we have. So let me refresh my code. Select. Okay. So here I want to basically count how many highs, how many mediums, how many lows do I have in here. So I have this column. So I say comma, count star. But I need to tell SQL, hey, I'm counting by the income group. So I say here group by income group. And we run this, we get a result. Maybe let's add a nickname to the count. So count as maybe like total or something like this. And there you go. So this is the result. A nice thing about SQL is that when you look at this query, I know that you can tell me what this query is. One not so nice thing of SQL is that thinking of this query might not be so easy if you don't practice enough. So practice is key here. I know that at first I see some people sharing screenshots with errors that's completely normal. So you have to practice and practice and practice until your queries are right. It's kind of like when you start learning a language, you kind of start understanding first what people are saying, but speaking it is harder. It's the same thing with SQL. You can look at this query and you can say, okay, yeah, this is one column. Here, this is another column, and I'm grouping by income group. But you should practice how to write that on your own without someone showing you. Um, so let's go with the next example. So the next example is gonna start to get interesting. Um, so here, okay, I'm gonna skip this example in the interest of time. But now let's go with having. So now we're gonna learn a new keyword in SQL, which is having. But to introduce that keyword, let's go back on our, oh, I didn't share the query. Let me share the query first. So you have it here. This is for the previous exercise. So there you go. I shared the query. Juno, you have a great question. So how does this star work? So this star just means give me all the columns of the table that you're calling. So from individual or from individual join drivers, whichever table it is. So in this case, the star is just like the count. So this is gonna work you shouldn't look at the star as a single thing. You should look at it as like the count column, which is in here. But you could actually say like comma star. This star on its own is just gonna add all the other columns that we have in individual. It's probably gonna just not really gonna make sense because we're not grouping by those. So you shouldn't put it in there. But it's just to show you that the star is just a shortcut of instead of writing every single column name, if you need to write all the column names, you just do star. But yeah, let me know if that answered that question. Okay, so the next situation that we could have is let's look at the income again. Income per gender. So we have select start from the suspects and well, actually, let's not do start. Let's do gender and let's do income. So we have gender and we have income in here. So let's say we wanted to know the average of the income overall. So select average income from the suspects. So let's run this query. So here we're just getting the income of all the suspects. So if I run this query again, is the average of all these suspects, the average income. If we wanted it per gender, we already did it. Select gender, comma, average income from the suspects, group by gender. So let me run this query. This is now not the average overall, but the average per gender. So you have here the gender, you have here the average income, and what you're grouping by. This is the same thing as the pivot table that we had done before. And let's say you wanted to know the total income per gender. Very similar, same thing. You can almost copy it and paste it. But you want the total. You want the sum of the income per gender. So notice that the total income of the women of the suspects is $102,000 and the total income of the male suspects is $116,000. Um, so what if you wanted to know, you wanted to ask, is there any group that makes more than $105,000 per year? So basically the answer is yes, it will be the men in the group are making more than 105K a year. The females are slightly lower below that. So how do we do that? If we have this, let me put it as the usual format that we have it. Usually we have it like this. If you might be tempted to say, oh, okay, I'm just gonna do where income greater than $105,000 per year. And I'm gonna run this query, but this didn't work. Why didn't it work? Because here it's filtering by the individual incomes. So the where is filtering by the individual incomes. So if I look again at the individual incomes of each one of these suspects in our database, none of them are higher than 105. So the where is filtering on each one of the rows and then doing the aggregation. And you might say, but what if I have this aggregation and I want to know on top of the aggregation, how do I know which groups make more than $105,000 per year? So you might be tempted to say, oh, that's because I don't need to filter per income. I need to filter on this column. So let's give this column a name as total. So I want to filter per total. I don't want to filter per income. I want to filter per total. And you might be tempted to say, okay, I want to say where total greater than 105. That should work, right? That doesn't work. It's going to give you an error. And the reason why, and you would have to ask whoever created SQL why they did it that way. I'm sure they must have had a good reason. Is that if you want to filter on something that has been aggregated, you can't use where. Where is only to filter on the each one of the single rows. You have to do having if you want to filter on anything that has already been aggregated. So the way you would do it is group by gender, having total greater than 105. Notice that I put the having after the group by. So having always goes after group by, and that's to filter by the aggregation already. So two things, two very similar things. So now I can use this visualization here. Two very similar things, where and having, where only filters on individual rows, having filters on aggregations. So if you want to filter on something that has already been aggregated, you should use having. And then when you're writing it, it should come after the group by, where the where comes before the group by. So something to keep in mind. This is a common interview question that they would ask you, tell me the difference between where and having in SQL. So this is like a good like flashcard to have ready at hand if you're interviewing and you have a SQL interview. So I'll put it in the chat. I also see a bunch of images that your TAs, your wonderful TAs are sharing that are super useful. Um, so for example, let's say you wanted to, let's go back to this individual one. And to answer your question, Drew, I just saw it. The program runs the query that you select. So here I selected this query and it runs this one. So here I have the individuals and I wanted to filter, let's say I wanted to know everyone that makes more than 50K a year. So here you would say, okay, from suspects where income greater than 50K a year, because I haven't aggregated this data. It's the individual rows. So now you filter it in here. Having wouldn't work because there's not an aggregation. So it will give you an error. So here you have to say where. So where, oh, this one. So there you go. Here is just filtering on each one of the rows. But if you wanted to filter on the aggregation, you have to use having. This is one of those things that I would strongly recommend you trying it on your own, looking at the difference, and having like a flashcard so you remember the difference between having and where. So let me put this query in the chat, see if there's any questions between the two. So basically, if you have a group by and you want to filter on the results of that group by, you have to use having, unless, as someone mentioned it in the chat, you could get creative and create a new view and then do a where on that. But if you want to do it on the same query, you have to use having. So maybe let's do a little bit of an exercise because practicing is where we see where maybe some confusion there might be. So let's look at the drivers table for a second. So let's get rid of all of this and let's remember drivers table. Select star from drivers. So in our drivers table, we have information about people. So let's focus on the hair color for now. So let's look at the hair color. So we have people that are blonde, red, white, brown, black, and so on. So let's say I wanted to count how many people for each one of these hair colors do I have. So you would say, okay, hair color, I'm going to count, give it a name to that. So as total from drivers. And I need to tell SQL, okay, group by, here I have a typo, group by hair color. And I run this, business as usual. It tells me, okay, how many people do I have per hair color? So far, so good. Let me copy this query in the chat. So now I ask you guys, what if I wanted to know what hair colors have more than 200 people of that hair color? So in other words, I want to know the hair colors that have more than 200 people. So the answer will be black, brown, red, and white. Not blonde, because blonde has less than 200 people. What do you use for this situation? Do you use where or do you use having? What do you think? And I love that I see a query already in the chat. Yes, so you do use having because we are going to filter on something that has already been aggregated on. So that's the next exercise. That's exercise number 5. Given that you already know it's having, I'll give you 1 minute to, oh, I almost showed the answer, to come up with the answer, and then we'll do it together. And the question says, with more than 200 drivers. So it is having. So you would say having total more than 200. Notice that it says more than 200 drivers. Now, 200 or more. So something to be mindful of when you're taking a job interview, that you're paying attention to the details. So what I said earlier was false because it wouldn't include brown. It has to be more than 200 drivers. If it was 200 or more, then you would put the equal sign, but not in this case. So there you go. If you try to do where, it wouldn't work. So it is having, because we have already aggregated on. So actually, you guys deserve a claps, because that was, I know that was a little bit tricky, and I saw everyone getting it in the chat. So let me put it in here. So where doesn't work in this case, because whenever you want to filter on something that has been aggregated on, you need to use having. So here, this is an aggregation. You need to use having. That's something that should come more naturally with practice, because this is just how SQL was created. They could have used where, and but they decided to have those two differently. So it's kind of like when you learn a language, you just have to learn the correct grammar. So I would suggest practicing. You can Google like SQL exercises of where versus having, and you get better. All right, so let's go back to our murder mystery. So we already know our suspects. So our suspects, we have our 4 suspects. Let me load these 4 suspects. So it says select star from the suspects. And we have our 4 suspects, but we already know that the license plate starts with CDI. So we could say, okay, where plate, like, and the placeholder, so CDI and the placeholder. And we see that our main suspect is Tris, but we shouldn't just accuse Tris, proven until innocent until proved guilty. So let's see what Tris has to say for himself. So let's look at this interrogation table. So we could say from, select description from interrogation where individual ID equals, I know it's 981 for Tris. So what does Tris have to say for himself? So in this query, we says, and let's see. So he says, I didn't know the deceased. I was just following orders. I met a woman on a blind date who I really liked. She promised me that if I killed the guy, she would be with me forever. Oh no, Tris, how could you fall for this? I believed her, but then she disappeared and it my calls. Like, really, Tris? What did you think it was gonna happen? Of course that was gonna happen, Tris. I remember her hair was blonde and her eyes were green. She said goodbye to me, and I watched her drive away in a Pontiac. On our date, she mentioned her love of private rock concerts, and she said she had not been one to one since 2016. So this is a plot twist because yes, Tris was the killer, but we have a second killer, the intellectual killer. We have to find who this woman was. So in this limited time, we have to query the individual table to be able to use the information that we were given just now and figure out who is this mystery woman. So let's do that next. So what do we know? We know, let me put this in here. I feel so pressure with the music. So these are the clues. So she's a woman. She is not as her hair colors. Her hair is blonde, and her eyes are green. And she drives a Pontiac. And then there's a clue about a concert. So let's start with those clues. We need gender, which we have in the drivers. We have hair, which we have in the driver's table. Eye color as well. And the car make as well. So we can just use the driver's table to get a list, first list of suspects. So let's do this. So select star. We want all the information from the driver's table. Where gender equals female, and hair color equals blonde, and what else? Eye color equals green, and the car make equals Pontiac. So let's run this query. And oh no, we have 3 suspects now. So we have these 3 suspects in here. So it seems like we need we have the driver ID. So maybe we can use this information from because we need the name, and the naming will be in the individual table. So we have these 3 numbers in here. So let's say select star from individuals, where driver ID in, and we need these 3 numbers. So I'm just gonna copy and paste. This copy and paste is not working. And I feel the pressure to solve this crime before we run out of time. We have 1 more minute. So we copy this, and this in here. And from this, let's see, no table individual. I have a typo in the visual. There you go. And now, okay, these are our 3 final suspects. Or first guilty person was Tris, but we're looking for one more. Is it Dookie? Is it Barry? Or is it Kia? So the next clue is in our date, she mentioned that her love for private rock concerts, and she hasn't been to one since 2016. So let's do that last one. So we know this from here. So let's look at these Facebook events. So let's put some music to make it more suspenseful. So select star from Facebook event, where let's just look at the shape of this table. Okay, we can use this individual ID. So where individual ID in, and it's going to be the IDs that were in this query. So let me run this query again. So 264, 402, and 514. And she hasn't been to a concert since 2016. So our suspect is suspect 402. And if we go back to this table, It is very mad. So thank you so much, everyone, for solving this crime with me. It's been a pleasure. I'm going to hire you next time as well. So we have our two final, no longer suspects, no, or two killers. First killer was Tris, and second killer was very mad. If we want to review this case and make sure that we caught the correct murderers, I'll send you the queries in the chat of the last few things that we did. But thank you so much for solving this crime with me. It's been a pleasure, and I'll give it back to Juan now. Thank you, everyone.